the way we manufacture things is not the best way to do it. So now there's a huge interest now to make things in additive manufacturing, and that's how 3D printing comes in. So these structures were predicted more than 100 years ago, but we couldn't be able to make them until the advent of a 3D printer. So we got some collaborators from Brazil. They did some molecular dynamics for this structure, predict their mechanical properties, and then confirm what schwarzites said more than 100 years ago. So the question was, how can you make them in a 3D way? How can you make them like big structures which you can use for different types of application? For instance, if you want to use this one as your structural member in a concrete or something like that one. So our friends from the Brazil, they did for us the molecular dynamics, and then we took the images from there, modeled them on a 3D printer, and then we were able to print them, and then print them with a very simple polymers.
And after that we go and do mechanical tests like compressive tests and impact tests, and we find that this structure has a high load bearing, and they are very light, and actually we can do several tests and we can, for example, stand up it and see that it doesn't break. And as you can see, nothing happened to this structure. They can tolerate a lot of weight. Our work opened new perspectives for engineered material.
The excitement for this structure comes from, when you look at it, first of all, they're beautiful. You love them. A key thing about this structure is a very lightweight compared to what you will have. For instance, if you print the same cubic structure without the schwarzite morphology, you will find out the weight is double what I'm holding in my hands. And kind of like, that's why we've been trying to push as much as possible to try and make as many as possible of this type of structures.